equation you're given to solve, the second question to yourselves should always be, okay, if it's polynomial, how many solutions do I have to get? Since it's polynomial and the degree is 4, then I have to present 4 solutions, even if they're all the same. In this case, 2 of them were the same. Good. Anything else? Anything else?
Can we do x over 3?
We're just looking to see. Yes, x over 3.
X over 3 equals x over 2 minus 3.
Good. So this is a linear equation because it doesn't have x in the denominator. I'm interested in getting rid of all denominators, meaning I have to multiply both sides by the least common denominator. So 6 over 3 will be 2x, 6 over 2 will be 3x, and 2 times 6 will be negative 12. So in a blink, I can change this into a regular linear, simple linear equation by eliminating fractions. Any questions? Any questions? Is this okay? So then we move 3x to the other side. Negative x equals negative 12, which means x equals 12. Okay, anything else? Anything else? Okay, so we are back to section 1.6, and you can always stop me if you have other questions. So we looked at 2 types. We looked at polynomial and radical. So I have other situations, like, for example, 42 on page 185. And this equation is quadratic in form. What does that mean, quadratic in form? It's not quadratic, but it can be replaced by a quadratic equation. So what's the use of that? Why do I have to solve an equation that is not quadratic, but change it into a quadratic equation? Because of its simplicity. It's much easier to solve a quadratic equation than anything else. So here's an example, which is 42. So this is x to the 4th minus 13x squared plus 36 equals 0. So now I know why we had difficulties with that, because I didn't present any example. So you caught me by surprise. I said, did I do this last time? And then I realized, I don't think I did. So that's why, yes. Okay, so this is degree 4. And I'm having some difficulty with factoring something like this. However, if I notice that there are 2 x quantities in here, this one is x squared and this one is x to the 4th. I'm looking at the one with the lowest power, and I'm going to say, what if I say, let t be x squared? And you can say, why are you complicating things? I'm really not. I am simplifying them. So I let t be x squared. Then if this is indeed t, now what is this? Because I cannot have t and x in the same equation. So if I take the liberty to replace x squared by t, then this must be
t squared.
If it is not, then I cannot use this method. So the applicability or the applications, or if you want, of the quadratic in form equations is limited. If the equation cannot be replaced by a quadratic one, then I cannot use this procedure. It's also called substitution. Why is it called substitution? Because I'm replacing x squared by t. So then, yes, this will be t squared. Can anyone give us the new equation? What is the new equation that we have to solve? Can anyone dictate? Yes? Yes. That's it. And this is not a big deal. to factor. So if you remember it's descending order, it's a trinomial. I will cover this for a moment and say, oh, I know. This is a perfect square, this is a perfect square, and this is minus. What do you expect? T minus 6 squared. But t minus 6 squared has what middle term?
Yeah, 12 plus 1.
Minus 12t, correct? But look what I have here. Oops. That method doesn't work here. But I should always try it first. So I'm looking for two numbers whose product is 36 and whose sum is negative 13. This is not too difficult because the leading coefficient is 1. So what do I have? So what is the factor form of t squared minus 13t plus 36? What do you think? Awesome. So the factor form of this t squared minus 13t plus 36 is indeed t minus 9 times t minus 4. Perfect. So we got two answers for t. And you can say, who cares about your t? Well, no one. No one does. We do, however, because it will help us solve the equation in x. So t equals and t equals. Can anyone give us two solutions for t? Of course, 9 and 4. But now this is a new equation, and this is a new equation that I have to solve. So what do I get? The first equation is nothing else but? Very good. X squared equals 9, which I know how to solve. We discussed 4 different methods for this equation. Which one is the easiest to apply now? Of course, because it's already set up. And what do I get?
3 and 2.
If I forget something crucial, I will not get the 4 solutions that I expect. Ah! Every time you take the square root, you're expecting 2 solutions because x squared equals 9 is a quadratic equation. Okay, the next one. What is this equation now? That's why from the very beginning we established 4 solutions. We're expecting 4 solutions. That's why you should always do those. You should always think in those terms so you don't forget. You can even write it down from the very beginning so you don't forget. That's why we put degree 4 here. Because I expect 4 solutions. Good. So what is the second equation that I have to solve?
Plus or minus 2.
So it's x squared equals 4. I take the square root plus or minus 2. So now is it clear where the 4 solutions are coming from? Any questions on the substitution method? Any questions?
So you just change x squared into the variable t to make it more.
But only if it's possible. Because, for example, in such an equation, let's say t to the third minus 2t squared plus 4 equals 0, even if you say this is y, you cannot say that this is y squared. Which means this equation is not quadratic in form, and I cannot use the method of substitution. So only if it's there. That's the point I'm making. Yes. Next question, please. Anything else? Do you think we need another example of this kind?
Yes.
Very good. So let's take a look at 52, in which we have x to 2/3 plus x to 2/5, I'm sorry. 1/5 minus 6 equals 0. X to 2/5 plus x to 1/5 minus 6 equals 0. I have no idea where to start, right? Because I see exponents that are fractions, but every exponent that is a fraction, what does this really mean? So if I say x to 1/2, what does that mean? This is very important to remember.
That it's x cut in half.
It's the square root of x. What about x to 1/3? The cube root of x. What about x to 1/5? The 5th root of x. What about x to 2/5? The 5th root of course. So kind of complicated. I don't want to even go there. The 5th root of x and the 5th root of x squared, I don't really want to. So what is my other hope? What is my hope? That I can do what? And I hope that this equation is in form. I'm hoping. Which of the two is the smallest power? Right. So I'm going to say, I'm hoping that this is quadratic in form. I'm going to say let y, let's say, is x to 1/5. But only if the first term happens to be not the coefficient. Only if the first term happens to be y squared. If it's not y squared, I can't. It's not quadratic in form. Only if this is y squared. Otherwise, I can't change the equation having x and having y in the same. So, but is it? So when I square this, I copy the base, and what happens to the exponents? Which operation do I perform with the exponents when I raise this to the second power? Correct. So 1/5 times 2/1 is that. So I'm safe. Can anyone dictate the new equation that we have to solve?
Is it 1/5 times 2/1?
So x
or
to
2/1?
1/5 raised to the second power. I copy the base. 1/5 times 2/1
Right.
is x to 2/5. But it's better to go back, and if you have questions, I'll be more than happy to. So I meant to equal here. So x to 2/5. So this is indeed y squared. If I denote this by y, this will definitely be y squared. So
y
yes,
squared
correct.
plus
Yes,
y
correct.
minus 6 equals 0.
Excellent. Which is a piece of cake, right? In comparison to what I just had, the 5th root of x squared and the 5th root of x and minus 6. This is a piece of cake. How do I solve this one?
Y plus
Very good. Y plus 3 and y minus 2. So there are two options for y. The product is -6 and the sum is +1. Perfect. So there are two options for y, and you can say who cares about y? Well, we do. So what is it? Y equals
-3.
perfect. And y equals 2. But what is this equation really? X to 1/5 equals -3. And can anyone dictate this other equation?
X to 1/5 squared. Oh, 5th, yeah.
I cannot change it to t squared or y squared, right? Y is x to 1/5. Good. So now this is a type of equation that we discussed last time. What type of equation is this? What does x to 1/5 mean? And then I'll know what type of equation is it. The 5th root of x. So what type of equation is it? Radical equation. Awesome. Yes. So how do I solve the radical equation? X to 1/5 or the 5th root of x equals -3. So the 5th root of x equals -3 and the 5th root of x equals 2. What do I have to do to eliminate the radical? Correct. In order to eliminate the 5th root, I have to raise both sides, not just one, but I know what you mean. Both sides to the 5th power. So then x equals negative. That's 81 times 3. 243. And then how do I solve the second one? Raise both sides to the 5th power. So then from here, I get x equals 32. Remember, they come with a question mark. We discussed that last time. I have to go back and check. But they will work. Both of them will work.
How do you, at the beginning,
Yes?
determine how many solutions you're supposed to get?
Very good question. I can't.
Oh, okay.
For this one, I can. Very good question. Perfect question. Thank you. I would have not mentioned it if you didn't ask. Because these are not polynomials. These are radical. This is a radical equation. For polynomials, if degree is 4, then I know for sure 4 solutions. If degree is 5, 5 solutions. If degree is 15, 15 solutions. But this is not a polynomial. Awesome question. Thank you. Anything else? So I have to check, but it's not a problem. I know that this would be correct. The fifth root of negative 243 is negative 3. The fifth root of 32 is 2. So both solutions work. Very good. Well done. Any questions for me? Yes? 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 Everything okay?
Can we get an honorable mention for this class?
If we can get past.
I'm just saying, I'm gonna try my best. I don't think I'm passing this class.
Why would you say that?
This is intense.
It is. It's college algebra. That's why we're here. That's why we work hard.
I agree. I'm sitting here like, should I drop this shit?
It's your education that we are talking about.
And 37 last semester.
We are
And
talking about your education and moving forward. So the answer is no, and the answer is put your behind in gear. Okay, that's why I'm here for you. Okay, ready? Yes.
I'm a little bit lost. X raised to the fifth. I understand that, but this is the way you have to use the square root.
So x to the fifth, it translates to x to the fifth square root of 5, whatever.
The fifth root.
The fifth root, yeah. So to get rid of the fifth
But
root, you have to multiply by the power of 5.
So can you say it again? Can you say the question again? Your phrase.
I got it all the way where it says x raised to the fifth is minus 3 because y.
So y was x to 1/5.
I understand
So
that.
x to 1/5 is the fifth root of x. It's a radical equation that we studied last time. So, well, it's studied a long time ago. This is just a review. So the fifth root of x equals negative 3. I have to raise both sides to the fifth power. If it were the square root, I would have raised everything to the second power. If it were the cube root, I would have raised both sides to the third power. Is that better? Yes. The fifth root requires the power 5. That's the only one that will eliminate the fifth root. Okay, last type of equation for now is the absolute value. Absolute value equations. Absolute value equations. Any questions for me? Is this okay? Did you have something else? Okay. So let's take a look at, let's say, problem 67. Again, this is review. We haven't started the material for this class yet.
So this is a review of what we should know.
Yes.
Oh, so
However, I presented everything from scratch. That's why I'm a week or so behind. Yes. Okay, ready? So 2. The absolute value of 3x minus 2 equals 14. So if you have any questions other than the material, wait till the end because we are so behind. And I'll be more than happy to sit down with each and every one of you. If you need help, I'm here for you. Okay, this is an absolute value equation. And like with every equation, I'm always asking myself, can I clean it up? Is there a way of cleaning this up? And I just have to remind you of something very important. The absolute value bars do not, or are not, first of all, they are not grouping symbols. You cannot put anything inside and distribute. You cannot factor out anything and take it outside, nothing. Nothing of that kind. This is something that is completely closed. We cannot put anything in, we cannot take anything out. So when I'm asking myself, how can I clean this up? The only answer is awesome, indeed. I have to divide both sides by 2. If you follow my lead at any point in time and you pay attention and you ask questions, it's impossible not to get a good grade in this class. That's my opinion. But you have to be on the spot. I mean, students came in early, asked questions, we sat down and we talked about problems. So you're more than welcome. That's why I'm here. I'm here for you. Okay? So what do I have on the left-hand side?
Absolute value 3x minus 2.
What do I have on the right-hand side? Very good. So here's the question now. Here's what I have to ask myself. What should I have in here such that the absolute value is 7? 5? No, because the absolute value of 5 is not 7.
7.
Or?
-7.
Correct. So this is how we write the solution. Whatever equals 7 or whatever equals -7. But what is my whatever? Here it is, 3x minus 2. Exactly what you just told me. You said that the inside quantity, which is 3x minus 2, could be 7 or could be -7. Perfect. Now I know how to solve these. Just one more time, let me say it again. No one can solve this equation because there is nothing we can do to it. The only path is to replace it by these 2 equations. So the first one, I move 2 and divide by 3. And 9 divided by 3 is 3. And the other one, I add 2. It's -5 over 3. And this is the solution. Let's look at another. Let's say 72. Any questions before we look at another?
Yeah. Oh, okay. All right, I got it.
Everything okay?
Yes.
Did we determine 7 and -7 because it was equal to 7?
Yes.
So say if it was
Yes.
4, we would do 4 and
Right.
-4.
So can I put 4 in here?
No,
Will
no,
the
no,
absolute?
no. I'm just saying if it
Yes.
was equal to 4,
Yes. Yes.
we would do the 4 and
Correct.
4. Okay.
That's why I was asking. Very good question. So then I say, what can I have in here? What I can have in here is only 7 and -7.
Right.
Good. So this is another absolute value equation. Let's clean it up. What do I need to do? Good.
And divide by 4.
Excellent. So now this is completely cleaned up. So therefore, I'm waiting for you to give me 2 options. So please understand that this is not a linear equation. This cannot be treated as a linear equation. This is an absolute value equation. That's why it has 2 options. So what are the options, please?
Um, 3 over 4, -3 over 4.
Correct. But what are the equations? I need to write the equation that I have to solve. So can anyone dictate?
1 minus 3 over 4x
Perfect.
equals 3 over 4.
Awesome. What is the other option?
1 minus 3 over 4x equals -3 over 4.
That's what I said. It's impossible if you pay attention. I repeat things so many different times that I'm sure at some point in time you're probably turning your ears off, right? So impossible if you come to class and if you ask questions and do the work at home, impossible. I refuse to believe that there is one student in this class who cannot do this. I refuse to believe that. But you have to put your heart into it. It's not going to happen otherwise. Good. So, yes. So I have to solve this. So I have -3/4 x equals 3/4 minus 1. I'm moving 1 to the other side. Or you can say, I don't want you to do this. Just eliminate fractions from the very beginning, and I'll do that. So you want to eliminate fractions from the beginning, or you want to move terms around?
Eliminate from the beginning.
Okay. So let's write the equation. So the first one is 1 minus 3/4 x equals 3/4. And in order to eliminate fractions, I will have to,
Multiply by 4.
that's it. I multiply everything by 4. So when I multiply 1 by 4, I get, good. When I multiply the middle one by 4, I get,
3x.
very good. And when I multiply the last one by 4, I get,
3.
that's it. So this is linear. We shouldn't even talk about it, right? We move 4 to the other side. Negative 3x equals negative 1, so x equals 1/3. The same thing with the other one. 1 minus 3/4 x equals negative 3/4 this time. Same procedure, meaning what?
Multiply everything by 4.
Very good. Let's do that. What do I get? The first one will be 4. The middle one will be
3x.
very good. And the last one will be negative 3. It's exactly the same equation, but just minus on the other side. So I move 4. Negative 3x equals negative 7, and x equals 7/3. And these are the two solutions. Any questions for me?
So when we answer this,
Yes. It's
will we-
enough if you just circle them like that, or if you want to put them in a
is it a solution?
in
set?
bracket. Yes, if you
Okay.
want to, that's fine. It's sophisticated and nice. Or you just circle them. I'm fine with either one.
But I think online it has to be.
Yes, that's true. They may. Very good. Any questions for me? Any questions? Okay, last section of chapter 1 is 1.7, inequalities. Inequalities. And we will look at only two types here. Linear, I should say 3. Linear, compound, and absolute value. Linear, compound, and absolute value. 3 types. 1, 2, 3. But the first one I shouldn't even mention, but I want to. I want to make sure that you have all the information you need. So I'm going to pick a linear inequality. And yes, 46 on page 203. 4x minus 3 divided by 6 plus 2 greater than or equal to 2x minus 1 divided by 12. And I know you're going to say fractions again. And then I'm going to say eliminate them again. There is always one step in which we eliminate fractions and we have no problems. So please don't ever be afraid of fractions. Good. So I'm looking at 3 fractions. One with a denominator of 6, one with a denominator of 1, and the last one with a denominator of 12. If I want to, and we should, eliminate all fractions, what should I do? Indeed, we have to multiply by the least common denominator, which is 12. It is a good idea, since we are talking about fractions, at least 2 of them, to multiply by 12 over 1, because it will be easier to see what we have to do. Here there is no point. And here is 12 over 1. Why? Because of course I will simplify first before I distribute. Of course I will simplify first before I distribute. Because if I distribute and I try to go back, it's going to be way more difficult. So I'll simplify by 6 and I get 1 and then 2 at the top. Can anyone dictate the first portion?
8x.
Yes.
minus
Let's
6.
write it for everyone first. You're way ahead of me, which is awesome. But let me write it so everyone can see. So 2 times 4x minus 3 plus. But you're right. It's 8x minus 6. I completely agree. You don't have to write this step. But I just would like to write it for people who are not on the same page. Very good. And greater than or equal to, and look, 12 and 12, 1 and 1. 2x minus 1. Is this okay?
Mhm.
Is everyone following? Is this okay? Any questions? Remember, the brakes are at your foot. If you don't put a brake and say, I want another example or something is not clear, then I have to move on. I don't have the brakes. I only have the accelerator. You have the brakes.
Why did you put a dash through the 6 and the 12? But
6 divided by 6 is 1. 12 divided by 6 is 2. 12 divided by 12 is 1. 12 divided by 12 is 1. That's why this side is 2x minus 1. This is 24. And this is 2 multiplied by 4x minus 3. Better? Good. Other questions for me? Anything else? Okay. So now this is more human, right, than we had before. Good. So please tell me what to do next.
Distribute the 2.
Very good. So indeed, 8x minus 6 plus 24 greater than or equal to 2x minus 1. Then, yes. So it's 8x plus 18 greater or equal to 2x minus 1. Only now I will start moving terms around. Now I will bring 2x and I will bring 18. So I don't have to write it all the time. So I bring 2x over, it's negative. So 8x minus 2x is
6x.
very good. Greater than or equal to. I'm taking positive 18 to the other side, it becomes negative.
7.
So I have negative 19. And then when I divide, I get x greater than or equal to negative 19 sixths. I want you to get used to the interval notation. The interval notation. So I hope you agree that negative 19 over 6 is negative 3 and a little bit. Would you agree? Negative 19 over 6 is a little bit to the left of negative 3. I don't care for units, but definitely this is negative 19 over 6. Which side will I find the solutions? Or solutions of the inequality? Which side? So let's read. So x is any number that is at least negative 19 over 6. So I'm going this way or this way? Right, correct. So because of the equal symbol, I would have to put a bracket. So this is the solution. I like to write x in the interval. So x is any real number in the interval, negative 19 sixths, comma, infinity. So this is what we call the interval notation. This is the interval notation. Quite useful.
X. Sorry, I didn't get.
Say it again.
I didn't get the part where you get the notation on the number line.
X is a number greater than or equal to negative 19 sixths. All numbers that are greater than negative 19 sixths have to be to the right-hand side of negative 19 sixths. Because of the equal symbol, I use a bracket. If it were not, if the equal symbol were not there, I would have used the parenthesis. Better?
So is that how we would represent the answer if
That's
it
it.
asked for it,
That's
or
the
if it
interval.
didn't ask for
That's
it?
the interval notation. Yes. Yes. Okay. Do we need another example, or can we move on to compound? Good. Very good. So let's take a look at 50. And 50, we have 6, x minus 1, minus 4 minus x, greater than or equal to 7x minus 8. What type of inequality is this? No, compound means two inequalities together. Linear. This is a linear inequality. So what do I do next? Good. So I have 6x minus 6 minus 4 plus x greater than or equal to 7x minus 8. Do we agree with this step?
Yes.
Everyone? Do we agree with this step?
Yes.
Is it correct?
Correct.
Good. What would be the next step then?
Uh,
Simplify both sides. Combine like terms. Clean it up. Very good. So I have 7x minus 10 greater than or equal to 7x minus 8. Very good. What would be the next step? I will move 7x and I will move negative 10. What happens when I move 7x to the other side? What do I get? 0. Very good. Greater than or equal to. When I move 10 to the other side, negative 10, it becomes positive. 10 minus 8 is 2. What do you think about this statement? If somebody says to you, it's better to have $0 in your pocket than 2. 0 is bigger than 2. What will you say?
false.
It's a false statement. And what do we conclude about this inequality?
No solution.
No solutions. We got a false statement. No solutions. Okay. Second type, compound inequalities. Let's take a look at 56. 3 less than or equal to 4x minus 3 less than 19. This is a compound inequality. Why is it a compound inequality? Here's why. You see, this is one inequality, and here's the other one. They are put together, two inequalities put together. However, this is not a difficult situation to work with. Why? Because I can work on all three sides at the same time. So I'm trying to solve for x. What would I like to eliminate first?
You want to get rid of the 3 from the middle?
Absolutely. So I will do what? I will add 3 to all three sides. So then I have 6 less than or equal to 4x less than 22. We added 3 to all three sides. Good. What will be the last step now?
Divide by 4.
Awesome. Very good. Awesome. So this is 3 halves, this is x, and this is 11 halves. I simplified. Now, this is the interval notation that I have to present. This is it. All I have to do is put a bracket at 3 halves and a parenthesis at 11 halves. So I will put a comma and I will say x is in the interval bracket because of the equal symbol. 3 halves, comma, 11 halves. I like to write x in. Let me explain why. Because if the interval is, for example, 1 comma 4, you may think that this is a ordered pair. 1 is for x and 4 is for y. But I'm fine if you don't want to put it in. It's okay. Any questions on compound inequalities? Do we need another example? Okay, very good. So let's look at another example with compound inequalities. Remember to redo all these problems at home. That's the first layer of understanding the topic, please. Okay. Let's say 58. And we have negative 6 less than or equal to 1/2 x minus 4 less than negative 3. All three sides. Very good. So this is the weakest link. This is what we want to do. First, we want to add 4 to all three sides. Negative 2 less than or equal to 1/2 x less than 1. We added 4 to the left-hand side, we got negative 2. We added 4 in the middle, we got 1/2 x. We added 4 on the right-hand side, we got 1. What is the final step here towards finding x? Very good. However, when I divide by a fraction, it is easier to say that I am multiplying both sides by 2. So multiply all three sides in this case by 2. The left-hand side becomes 4. Careful. Yes. The middle side becomes very, very good. And the right-hand side becomes, and this is the interval notation. It's right here in front of us. So bracket at -4, comma 2 with a parenthesis, and I put x in, so it's clear that this is the solution. And these are compound inequalities.
You don't flip the signs when you multiply.
Not when I multiply by a positive number. So let me say this.
Right.
So let's say I have -2x less than or equal to 4. This is a different problem. I just want to answer a question. So -2x less than or equal to 4, what would you say we need to divide both sides by? Right. So this is x and this is -2. What do I have to do now?
Flip the sign.
Indeed. I have to flip the sign because I divided or multiplied by a negative number. Is that clear? Do I need to explain?
Oh, so basically right there, I think, if you know where you put the 2x, -2x, usually like the way I basically was, if I can understand right now, it's basically just put a -2 under it. You just divide it by -2x.
Okay.
Because you're dividing the other side.
You
by
cannot
-2.
divide by -2x.
No,
You can only divide by -2.
-2. But
Correct.
if you put it under it, then you realize that you need to put the sign is 2.
Okay, fine. Whatever works.
If you just put the x in the bottom, and I forget.
You cannot put x in the bottom. You cannot divide by x. Be very careful. Okay, so is this clear? Do we understand why we switched the symbol? Yes. Do we understand why? Everything okay? Yes?
That's only when they're divided.
Yes. Let me give a numerical example. So is 2 less than 10?
Yes.
Let's say for whatever reason we want to divide both sides by -2. So this side is -1, this side is -5. Is this still true? Is -1 still less than -5? No. So every time we multiply or divide by a negative number, we have to, of an inequality, of course, we have to switch the inequality symbol. Okay, last type here is absolute value. Absolute value inequalities. I'm going to start with a very simple numerical example. And then we'll look at more sophisticated problems. Okay, ready? So here it is. So absolute value inequalities are only 2 types. This type in which the absolute value is less than or maybe less than or equal to a number. And this is the other type in which the absolute value is greater than or just greater than or equal to or greater than or equal to a number. Okay. They are completely different. Let me tell you what the first one is telling me. The first one is telling me, by the way, what is the absolute value of x? What does it mean? The excellent.
The what?
So the absolute value of x is the distance from 0, between x and 0. So here's what the first inequality is telling me. Find values x, any number. Find any number that I call x, such that the distance between all those numbers x and 0 is 3 units or less. One more time. The first inequality is telling me to find all numbers x whose distance from 0 is 3 units or less. 3 units or less. Again, we cannot solve this inequality. No one can solve this. I have to change it into what it is equal to or equivalent to. So what did I just say? Where will I find x?
I think 3 numbers of x.
So, correct. -3 less than or equal to x, less than or equal to 3. So this first inequality translates into everything between -3 and 3. Very good, thank you. So on the real line, or number line. This is -3, this is +3. Notice that I don't care for units. This is just an illustration of what we are trying to do. So -3 to 3 is this interval. So the solution of this will be x in the interval -3 to 3. And we will look at examples in a minute. And it's clear because a number here will have a distance from 0 less than 3 units. A number here will have the distance from 0 less than 3 units. Now let's look at the second possibility, second type of inequality. What does the second one tell me? It says this. Find x values whose distance from 0 is 3 units or more. Okay, one more time to see the difference. 3 units or less, and the second one is 3 units or more. So again, if I don't know how to convert this, I will not be able to solve it. So this one gets replaced by 2 completely separate inequalities. This one was nice, was like a chain. I'm able to solve all 3 at the same, both inequalities at the same time. But this one is not, because for this one, I want 3 units or more, not 3 units or less. So where will I find those numbers? X to the right of
3
perfect, or x
to the left than -3.
perfect. That's the correct answer. Meaning this. This is what it means. This portion and this portion. So these two go with this inequality. The middle part goes with this inequality.
But
So-
wouldn't you write that inequality in the sense of like, let's say -3 is less than 3, x, and greater than 3.
Impossible. Let me explain.
No, I'm just saying like if it's gonna be
Impossible.
infinity, if it's infinity from
Zero. Impossible. Let me explain. The inequalities can only be this way or this way. There is no such thing. Do not write it, please. I don't know. Doesn't matter what you learn. This particular one I have
I
to
never
correct.
learned that. I was
No, this particular one I have to correct. There is no such thing. Okay? So the inequalities go this way or this way. This does not exist. So, coming back to write a solution. So let's take a look at the solution. The solution is written as x in the interval -∞ to -3 union 3 to infinity.
Oh, yeah.
Okay? So as you notice, what would you say between these two inequalities? Which one is a little bit more difficult? The first one or the second one?
Second one.
Of course, because first of all, I have to remember several things. Number one, I have to determine the outside. There are 2 separate inequalities. They cannot be solved together. Secondly, I have to remember that the solution has to have the union in between. So it's definitely more difficult. Let me choose problems from both